So now let's draw the product that we would get after these two steps. And let's try to draw it so it looks as much like our destination as possible. So what's going to be our product after these two steps?
Isn't it already, let's see here.
When we combine this with this and then this, what intermediate are we going to get? Let's try to draw a picture of that. Definitely use the numbers. If we use the numbers, it shouldn't be too hard to see who's going to be connected to. So let's put some numbers in that picture. Okay, good.
Oh, and 1, 2, sorry.
Now we already know that the number 3 is attached to the number 4.
Correct.
I'm moving the number 4 down here because I want to make room for the new group. Because I want to try to draw this intermediate as much like the product as possible. Now who's the number 3 forming a new bond with? The number 1. And the number 1 is bonded to the number 2, which is a carbonyl. So now we're really starting to get closer to the product that we were trying to make. So again, the sequence was we made the alpha carbon into an enolate, and then it did an SN2 on the number 1 carbon. And again, the trickiest thing was coming up with this fragment that we needed to have the enolate attack. But I think the numbers helped us.
Okay, and at this point, we could add, we could either do a base catalyzed hydrolysis or the acid catalyzed hydrolysis, and it would make 2 carboxylic acetors. And then on the beta one, number 4 is what we would decarboxylate that one, and we'd be left with our product.
I think you figured out the whole rest of the problem. That's right. So what are the changes that we need to make here in order to make it look like this? Well, one thing we have to do is we just need to cut off the number 4 carbon.
Correct.
Something else we have to do is change the number 2 carbon into a carboxylic acid. However, we can accomplish all of that with pretty much just hydrolysis and heat. Because just like you said, hydrolysis will turn both of these into carboxylic acids, and then heat will decarboxylate this.
Okay.
Again, the simplest thing would just be doing acid catalyzed hydrolysis and heat. Your instructor's got it all complicated again, so I guess the way he's got it in his notes, though, is the way it's given on the test, so we'll keep drawing it the way that he's doing
Yeah,
it.
because I think he takes those notes from the book.
Okay. The book is a little bit weird, but this is still the most likely way to see it on the test, so I'll keep
As long as I
following
can
up on
recognize that. I'm putting that down and in
Right.
parentheses of just the acid hydrolysis.
So after the base catalyzed hydrolysis, we would have 2 carboxylates. And then after he adds the acid, we would have carboxylic acids.
Okay.
And then the heat would finish things off. You could just add the heat together with this step over here, but we can think of it conceptually different. Now, which of these carboxyl groups are we going to lose? The one on the 2, the one on the 4, or both?
The one on the 4, because it's the only beta carboxy group.
Beta carbonyl carboxy group. So where's the beta carbon here? Well, here's the number 4 is alpha carbon, and here's the number 4 is beta carbon. So the number 4 really is a beta carbonyl carboxy group.
Okay.
So that really is going to decarboxylate. But where's the number 2's beta carbon? Well, this is the number 2's alpha carbon, and this is the number 2's beta carbon. So the number 2 is not a beta carbonyl. So we don't need to worry about this decarboxylating, which is good because we didn't want to lose it in the first place. How many carbons do we lose when we do a decarboxylation?
The one.
Yeah, so you can see that the only difference between this picture and this one is we just lost the number 4. We just lost the number 4. Okay, so that's another example. I don't know if this would be technically called acetoacetic ester because we didn't quite start with 2 carbons and 2 carbons, but it's the same basic idea. If you're starting with a 1,3-dicarbonyl ester, what can you do with 1,3-dicarbonyl esters? Well, you can add extra carbon chains to the middle carbon, and then whenever you feel like it, you can blast off the ester group. So anytime we've got one of these 1,3-dicarbonyl esters, we can add extra carbon chains to the middle carbon, and then with hydrolysis and heat, blast off the ester group. And that ends up giving us a substituted ketone. Okay. We ended up with a substituted ketone over here. Again, this was the hardest step, coming up with this fragment.
So now in just the nomenclature or product, would the carboxylic acid supersede in the naming?
I always have a hard time naming things when there's both a straight chain and a ring. I hope he wouldn't ask you that. He didn't actually give a name for it in the answer key. Oh no, he called it, no, he just called it this compound. Okay.
All right, so that's fair enough. I was just wondering.
Yeah, I could try to figure out the name. That's probably not the best use of our time. Okay. The thing that was crucial here was to see we're going to lose the number 4 carbon. We're not trying to turn the number 4 into this. This is what we're going to lose. We're going to add a whole new carbon chain to the number 3 over here. That was your first guess, I think, that you were going to turn this into this. But this is what we're going to lose when we do the hydrolysis and the decarboxylation. We're going to add a whole new carbon chain. And for some parts, the carboxylic acid part didn't really matter. What mattered was putting a good leading group on the number 1. However, we can't start with a carboxylic acid here because that would interfere with our reaction. We can start with an ester. It's perfectly okay to start with an ester because it's very easy later on to turn that into a carboxylic acid with hydrolysis. That's obviously a good one to mark again and try again on your own. Those aren't easy. All right, so much for that acetoacetic ester synthesis. Now we have the malonic ester synthesis. Which is a pretty similar idea. The malonic ester synthesis. Incidentally, this is a 3-carbon dicarboxylic acid, right? A 3-carbon dicarboxylic acid. It turns out that the common name for this is malonic acid. So you can see why this would be called a malonic ester, because it's an ester that's formed from malonic acid. So this is the malonic ester synthesis because we start with an ester that would be formed from malonic acid. That's a technicality. The key thing is that notice that in this synthesis, we started with a 1,3-dicarbonyl with 1 ketone group and 1 ester group. And now we're starting with a 1,3-dicarbonyl with 2 ester groups. So that's the only big difference. The only big difference between these two cases is here, we only had 1 ester group and 1 ketone. And here we have 2 ester groups. But we're going to do the same basic thing as before. We're going to talk about how to add carbon chains to this alpha carbon. We're going to talk about how to add carbon chains to this alpha carbon. We could add either 1 carbon chain or 2 carbon chains to the alpha carbon. They don't have to be the same, even though I'm using R for both of them. And then after we add the carbon chains to this alpha carbon, we want to get rid of this ester group. Well, how can we get rid of this ester group after we add the carbon chains to the alpha carbon?
By making it a carboxylic acid and decarboxylation.
Right, by doing the hydrolysis. But notice that if we hydrolyze this ester, we're going to inevitably hydrolyze this ester too. That's why we end up with a carboxylic acid over here. But otherwise, that's very similar to what we had here. So in this case, there was only 1 ester. So when we did the hydrolysis, we still kept the ketone on the left. But now on the left, we don't have a ketone, we have an ester. So when we do the hydrolysis, it turns into a carboxylic acid. But we're not going to lose this carboxylic acid because it's not a beta carbonyl. We're only going to lose one of them. So it's important to compare these two. So when do you use this? You use this when you want to substitute the alpha carbon in a ketone. This is a good way to form a ketone with a substituted alpha carbon. A good way to form a ketone with a substituted alpha carbon. And this is a good way to form a carboxylic acid with a substituted alpha carbon. This can form a ketone with a substituted alpha carbon, and this approach is a good way to form a carboxylic acid with a substituted alpha carbon. So if you want to end up with a ketone, start with a ketone and an ester. But if you want to end up with a carboxylic acid, start with two esters.